Hello one and all, and welcome to the second video from Edexcel's GCSE higher tier series from November 2022. Calculator paper this time, so paper 1's been and done. Paper 2 again has 24 questions, and again it's a mixture, as you can guess, of some easier, some harder, some fairly fiendish. So I'm going to talk you through all the questions here, and calculator methods included, and sometimes I'll show more than one method, but as I say, any method is valid unless I state otherwise in this walkthrough. So let's get straight to it, shall we? Let's have a look at question number 1, what that was and how to solve it. Question 1 on this paper, it was about a scatter graph showing information about the amount of rainfall in millimetres and the number of hours of sunshine for each of 10 English towns on the same day. One of the points is an outlier, it says. So what does the word outlier mean? Well, put simply, an outlier is just something that doesn't fit the general trend or pattern. So if you can see here, these points tend to be going downwards as you read left to right in a sort of straight line, and we're going to mention a line of best fit in a moment, but this point here doesn't seem to be along this straight line. So this one here is a bit out of it, not really following the pattern. So for that reason, this point here is the outlier. So it's 2 along and 1 up, so the coordinates of this outlier are 2, 1. Part B, ignoring this particular outlier here, describe the relationship between the amount of rainfall and the number of hours of sunshine. At this point, even though the question doesn't ask us to, I would suggest drawing in a line of best fit, not thinking about this outlier here. So avoiding this outlier, a line of best fit would be the line through the general trend of points. So roughly speaking, it's going to go through here, and as a rule of thumb, as a rough rule, try to have the same number of points above the line as below the line of best fit. So my line of best fit I'm going to add on here, like so, and then looking at the direction of this line as you read from left to right, that tells you the correlation. Because it's going downwards as we go from left to right, it's negative correlation. So the bare minimum you could say to get this question right would to just be say it's a negative correlation between the two. So negative correlation would be accepted. But the best way to describe the relationship, in my opinion, is to use words and context. So you can see here, in general, as rainfall increases, that tends to mean a decrease in the number of hours of sunshine. So something like this would be ideal. As rainfall increases, the number of hours of sunshine decreases. Then in brackets, I've just put here, you could have just said negative correlation. You could have also said something like, as rainfall decreases, the number of hours of sunshine increases. The same thing essentially, just said the other way round. Part C, it says on the same day in another English town there were 7 hours of sunshine. Using the scatter graph, estimate the amount of rainfall in this town on this day. This is where a line of best fit really comes in handy. So what we can do here is we can read off on our grid at 7 hours of sunshine until we hit our line of best fit, then read down and work out the amount of rainfall estimated from our line of best fit. So on mine, which might be different to yours, which is okay, 7 hours, I read off here, then go down, and for my line of best fit, I'm getting a value of about 3.3. So that's what I'm going to put here, 3.3 millimetres. Now, if you're at home and you've drawn your line of best fit and you're thinking, well, my line of best fit, I get 3.6 or 3.8. That's fine as well. The examiner will give you what's called tolerance. So as long as you draw in a correctish line of best fit, the examiner would have accepted anywhere between 3 millimetres and 4 millimetres inclusive, based off a line of best fit. If you're less than 3 or more than 4, you would lose a mark because that's showing your line of best fit isn't quite drawn accurately enough. Question 2 is about views of the 3D shape. So we have a front elevation and a plan of a solid shown here. This is the front based on the direction of the arrow, as an imaginary person would be looking at it, and the plan just means looking at it from the top down. So thinking about this, if we want to draw the side elevation, well, looking at it from the side as shown, we'd be able to see that it's 1, 2, 3, 4, 5 squares high. And in terms of width, if this is a plan view, we can see that it's going to be 3 squares wide. And so the first thing I would suggest would be to draw a rectangle, 3 wide and 5 high, which shows our general side view. So that's some marks already, but actually we could add a bit more detail to this. So looking straight on, it's 1 square up, and then it's like a roof in my head. It sort of cuts back here, and so we could actually see this edge if we're looking at it. It'd be an edge which is 1 square high. So if I imagine this as like a green edge, that would look going across, as you look at it from the side, that would be a straight line going across 1 square high. So it slopes like 1 square high, so we can add in this green line here. And as well as that, this roof, I know it's not really a roof, but it's looking to me like at 3 squares high, this first roof ends. Okay, so again, we could perceive that if we were looking at it from the side. We'd be able to see where one roof ends, falls back, and another one begins. So we'd be able to perceive a change in slope 3 squares high. So again, we can add in another line going straight across 3 squares high, and that will represent the change of roofs, essentially. So that's the full side elevation, and so that's the bare minimum we'd need, but sufficient in itself to get us full marks. Question 3, we have a arithmetic sequence, 7, 13, 19, 25, and 31. It says here to just find an expression in terms of n for the nth term of this sequence. So first of all, it's always a good idea to consider what the terms are going up in. And so from 7 to 13, from 13 to 19, and so on, hopefully you can see that the sequence is going up in 6s. Because it's going up in 6s, we can therefore say it's definitely something to do with 6n. So it's like 6n, like the 6 times table. It's going up in 6s. However, this sequence here is actually starting off 1 higher than what the 6 times table starts as. The 6 times table, as you know, starts with 6. This number's 7, so it's actually 1 higher than the 6 times table. So 6n, because it's going up in 6s, plus 1, because it's 1 higher than the 6 times table. So we just have 6n plus 1. Part B, we have a different sequence this time, which is 8 minus 6n. We're now asked, is minus 58 a term of a sequence? You must show how you get your answer. There's 2 main ways in my mind of doing this. The first one would be to solve an equation. So we could set 8 minus 6n, and we can see, is that ever going to be equal to minus 58? So just solving this equation, what I'd suggest we do, get rid of a negative 6n by adding 6n to both sides. We'd then have 8 equals minus 58 plus 6n we've just added. If we then add 58 to both sides to isolate the 6n on its own, then we'd get that 8 plus 58, which is 66, what am I thinking? 66 equals 6n. Then finally, to get n on its own, get my words out, we can divide both sides by 6. So 11 equals n. So the conclusion here is therefore yes, minus 58 is in this sequence. It is the therefore 11th term. If we had got a value here which was a decimal, for example 10.5, we'd interpret that in terms of minus 58 would be in between the 10th and 11th. But because we end up with a whole number value, that shows that it is in the sequence. So using this method, a whole number value says that it's in the sequence. A decimal or fraction would mean it is not. Because 11 is a whole number, therefore this is in the sequence, and therefore is the 11th term. So yes, in brackets, it is the 11th term. So that's the direct approach using algebra. But as I know myself, exams can be stressful, as I'm sure you know. So what if the algebra had fallen out of your mind? Is there another way of doing this? Well, fortunately for you guys and girls, yes, there is. What we could have done instead would have been to generate the first few terms of this sequence. So we could have started, for example, when n is 1, we'd have 8 take away 6, which would be 2. When n is 2, the second term would be 8 minus 6 times 2, which would be 8 minus 12, which is minus 4. So therefore, we could have chose to generate the sequence ourselves manually by just writing down the first few terms, and then just spotting the pattern that start with 8 and then going down in 6s. So the first term, as I say, would be 2, then minus 4, and so on. So generating this, you'd actually see, it's a bit tedious, but actually you would run into minus 58 along the way. So although this is a tedious method and not the most sort of sophisticated, it would give you full marks because it is valid. So you could actually just count along and say to the examiner, yes, look, it's the 11th term along, therefore, yes, minus 58 is indeed a term of this sequence. So algebraically here, or doing it purely numerically, either way is valid. I'd suggest the algebraic way is better. For example, if you were trying to see if minus 5,000 and something was in the sequence, this would take quite a long time. Question 4, we have a plan of Jason's garden. So we've got two rectangles here and here, and a right angle triangle there, and importantly, AFO, from A to F to O, this here, is a sector of a circle with centre O and angle AOF equals 90 degrees. So the question goes on to explain he's going to cover his garden with grass seed. Each bag of grass seed covers 14 square metres. So this unit here is a massive giveaway that we need to work out the area, because M2 is a measure of area. So what we're going to need to do here is to work out how many bags of seed he needs to buy, because he's going to cover his garden with grass seed. We need to work out the area of this horrid shape. So what I'm going to focus on first of all is this bit here when it says about AFO. It's a sector of a circle with centre O and angle AOF here is 90 degrees. Well, we know that a full circle is 360, and therefore half of a circle is 180, and divide that by 2, you get a quarter of a circle, which is 90 degrees at the centre. So we need to realise that AOF is actually a quarter of a circle. So this bit here, AOF, is a quarter of a circle. So what we need to remember now is how to work out the area of a full circle. Well, the area of a circle you need to know really is pi times its radius squared. So we need to know the radius of this quarter circle. Well, we've told the centre of the circle is O, which is here, and obviously F is the edge. So from O to F is the radius. So from O to F, if we just look down, because this is a square, well, it's my bad, it's a rectangle, 9 and 7, silly me. Because this is a rectangle, the bottom will be the same length as the top. So if ED is 7, we can think that obviously F to O must be 7 as well. So therefore, we know the radius of this is 7. So using pi r squared for the full circle, we can just now do shift pi times 7 squared, that's a full circle, divide it by 4 because you've got a quarter of a circle. That tells us that the area of this yellow bit in exact form is 49 over 4 pi. I'm going to leave it in exact form for now. We can change to a decimal later. So this area here is 49 over 4 pi, which I'm going to label on now. The next shape I'm going to look at is this rectangle at the top. This is 11 by 7. The area of a rectangle is the length times the width. So 11 times 7, this is 77. Looking down here now at the second rectangle, which is 9 by 7. This area is 9 times 7, which is 63. Finally, the triangle, this in purple, we need to remember what the area of a triangle is. So it's base times height divided by 2. So we need to remember this one here, half times base times height is another way of saying it. So from one end to the other, from O to C is 11. It's the same as from A to B, of course. So that's 11. The height of it, going down, is 9. So we're going to do 11 multiplied by 9 and half it. Or, as I'm saying here, using the formula I've just wrote down, in fact, I'll stick to my own words. Half times base, so 11 along, times a height of 9. That's going to give us 99 over 2, or 49.5. So the total area of this garden now is going to be all these different areas added together. So if you do this on your calculator, 49 over 4 pi plus 77 plus 63 plus 49.5, what you should find is the total area of this garden comes to 227.98 blah 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 meters squared. So from here what we need to do now is consider the rest of the question. He's going to cover all of this area of 228-ish square meters with garden seed. Each bag, he says, covers 14 square meters of garden. So how many bags are needed to cover 227 and so on? Well, the total bags needed would be the total area that needs to be covered, this 227.98451 figure, divided by 14. That'll tell us how many bags are needed for covering this full area. So if we just do that on our calculator now, 227.89451 and so on, divided by 14, let's see what that gives us. Divide that by 14. We get here 16.284 and so on. So that's how many bags are needed, 16.284. So 16 bags wouldn't be enough, and you can't go into a shop and ask for, can I just have 0.284 of a bag? Because 16 bags wouldn't be enough, therefore 17 bags are needed. Because obviously you can't just buy a fraction of a bag. It wants to know though how much it will cost, not how many bags. So we're almost there. We've got 17 bags, but now what we need to do is to work out how much that would cost in total. Well, each one bag costs £10.95. So if we're buying 17 of those bags, the total cost must be 17, because it's 17 bags, multiplied by that cost of £10.95 for one bag. And if we calculate that correctly, we're home and dry and have done the question. So 17 multiplied by £10.95 is the final thing to do. 17 times 10.95 equals £186.15. So that's question 4 done. A fairly tricky question 4 because it's quite wordy. So well done if you've managed that one. 186.15. Question 15. Work out the value of x. Give your answer correct to 3 significant figures. A quick spot here, we can see it's a triangle and it's right angled. You should be thinking, because it's a right angled triangle, it's either going to be Pythagoras or SOHCAHTOA. Pythagoras is if you know two sides, you're trying to find a third. This one isn't like this, therefore it must be standard trigonometry, SOHCAHTOA. So here they come, the infamous SOHCAHTOA triangles. What we're going to do now to work out which one we need, I'd always suggest to label the sides. So this angle's 53 degrees. I'll just get my hand up here. There we go, my magic hand. 53 degrees. Opposite to the angle is called the opposite side. So I'm going to label the opposite O. The longest side is called the hypotenuse, and it's always opposite to the right angle. So in our case, the hypotenuse is 14.5. The other side I label last. If it's not O or H, the other side is A. Now what we need to consider is what side we know. Well, we're told the hypotenuse is 14.5, so we can colour in or highlight H on the SOHCAHTOA triangles, like so. That's the side we know. Next of all, I'm going to highlight the side I want to know. I want to work out x, which is the adjacent A. So if I highlight the A side and also highlight A in the SOHCAHTOA triangles, like so, we can see here that the triangle which uses both pieces of information, both a piece we have and want to have, is CA. So for that reason, we're going to go for the CA triangle. O, we don't know, we don't want to know, so we can essentially forget O, like so. So next up, using our hand or thumb or finger, we just cover up the one we want to know. So we're trying to find the adjacent side. We're going to use the CA triangle because it's the most coloured in one. So if I cover up A for adjacent, then A, you can see, is C and H next to each other, therefore the adjacent. Two things in algebra next to each other means we multiply them. So A is C times H. C stands for cosine or cos of the angle in question, which is 53. H stands for hypotenuse, which of course is 14.5. So that's the calculation we need to do. Importantly, when you're doing cos of an angle, close off the bracket. That is crucial. So what we're going to do here is cosine 53, close brackets, multiplied by the hypotenuse, which is 14.5, press equals, we get 8.72, but because we're rounding it to 3 different figures, we have 872. However, next to this 2 is a 6, which is 5 or more, so this 2 gets pushed up to a 3. So the final answer, x is 8.73 to 3 significant figures. And of course, we're talking in centimetres, so we may as well add in cm. Question 6. Ella is going to invest £7,000 for 2 years in an account paying compound interest. So in the first year, the rate of interest is 3%, and the second it goes down to 1.5%. Work out the value of Ella's investment at the end of the 2 years. the key piece of information I'd always give students to start with is that before anything happens to a value, we always start off with 100% of its original self. In the first year, we're told the rate of interest is 3%. Now, interest is a positive thing. Interest, if something's interesting, that's positive. So interest means the amount's going to get bigger. So the interest rate, first of all, in the first year is 3%. We start with 100%. We're going to add on 3%. So 100% plus 3% plus, because it's interest, 3% is 103%. Then to change to a decimal, which is called the decimal multiplier, we divide the percentage by 100. So 103 divided by 100 gives us a decimal multiplier for the first year of 1.03. In the same way, we consider the same thing for the second year, where the rate of interest goes to 1.5%. So again, it's going to be an increase because it's interest, but this time the percentage increase is 1.5. So at the start of the second year, we're going to start with 100% of its value at the beginning. So we're still going to start from 100, then we're going to add on 1.5%. 100% plus 1.5% gives us 101.5%, sorry. Then dividing the percentage by 100 to change to a decimal multiplier for the second year, this one divided by 100 gives us 1.105. So that's the decimal multiplier for the second year. So now, putting these two together, we're perfectly placed to actually work out the value of Ella's investment. So she starts off with £7,000. The first year, it increases by 3%. So the decimal multiplier for an increase of 3% is 1.03. So this tells us how much it'll be worth at the end of the first year. And then the second year comes, and then we're going to increase by 1.5%, which is done by multiplying by the decimal multiplier 1.015. So that's the calculation we need to perform on the calculator, which will tell us the final value of the investment. So 7,000 multiplied by 1.03 multiplied by 1.015, that gives us a value of £7,318.15. Just check I've remembered all those figures right. 7318.15, yes I have. So that's the final value of Ella's investment. Question 7, we have a quadratic graph. For part A, we have to write down the y-intercept of a graph of y equals x squared minus 6x plus 4, which is obviously what this graph actually is. So the y-intercept just means where we cross the y-axis. We can see here this graph crosses at 4, so therefore the y-axis intercept is just simply 4. If you put 4, 0 for the coordinate, that would have been accepted too. Next, we're wanting the turning point of a graph. The turning point of the quadratic is just where it changes direction. In other words, where it goes from going down to going up, or from going up to going down if it's a negative signed x squared term. Here it changes direction here at the very bottom. This is where it starts going up instead of going down. The coordinates of this point here are 3 along and minus 5 down. So therefore, the turning point of this quadratic is 3 minus 5. For part C, we need to use this graph to find estimates for the roots of x squared minus 6x plus 4 equals 0. If we just spot here, x squared minus 6x plus 4 is the same as x squared minus 6x plus 4, which was this graph we've actually had drawn for us. And so x squared minus 6x plus 4 is this whole curve here. Now in this scenario, when it mentions about roots, it means solving this equation when it's equal to 0. And so x squared minus 6x plus 4 varies where it's very high here, quite low there. We want to find when it's got a height of 0. So we're wanting to see when it's 0, and it's got a height of 0 and it crosses the x-axis. So we're wanting the values of x which are here and also there. And so if I just use this with green lines to emphasize the roots are in green, where these green arrows are pointing, be as accurate as you can. I make this one about 0.8 and this one over here to be 5.2. So the roots are 0.8 and 5.2. If you've not got exactly those same roots, that's okay, as long as you're no more than 0.1 more or less than these answers here. So anything in between 0.7 and 0.9 inclusive will be okay for this root. Anything between 5.1 and 5.3 inclusive will give you answers and full marks for this root. Question 8, we have Shanda, who buys a necklace for £120 and she sells it for £135, and we need to work out her percentage profit. First of all, let's work out the profit before we work out the percentage profit. All profit is the difference between what you sell something for as a difference between what you bought it for. So it's a sell price, subtract the price you bought it at. So we need to minus the cost price. So she sold it for 135. She bought it for 120. So she's actually made an extra £15. So her profit is 15. Now we don't want to work out her profit just, we want the percentage profit. There's a general formula for this. So essentially, percentage whatever that might be, is the whatever in question, in this case profit, is a fraction of the original amount times by 100. So to go from the profit to the percentage profit, we can just therefore do percentage profit is therefore the profit we've worked out from that first step, which is £15, as a fraction of 120 multiplied by 100. So on the calculator, if we just work this out step by step, then what we should get, 15 over 120 multiplied by 100 should give us 12.5. In other words, 12.5%. And that's our final answer for question 8. Question 9, we have two different equations of two straight lines. The first one is y equals a half x minus 6. The second one is 6y equals 3x plus 7. Oscar says that these lines are parallel. Is he correct? Give a reason for your answer. For this question, I'd suggest we need to remember the standard equation for any straight line, which is y equals mx plus c. So in other words, we want y to be the subject. So m is the gradient, c is the y-axis intercept. But if two lines are parallel, what this means is gradients must be the same. So for the first one, we can see the gradient quite clearly. The gradient is just the number in front of the x when we have it in the form y equals. The number in front of the x here is 1/2. So therefore, the gradient for this one is a half. So for line 1, gradient equals a half. So if I just call that 1, I'll call this one 2. Now line 2 isn't in the form y equals mx plus c, because it's 6y rather than just 1y. So we can easily alter this by dividing both left and right by 6. So if we divide both sides of the equation by 6 for this one, we get that y is going to equal 3/6 of an x, 3 divided by 6 x's, plus 7 divided by 6, because we need to divide all bits by 6. Of course, so this simplifies because 3 over 6 is the same as a half. So we get y equals a half of an x plus 7 over 6. And now you can see that the number in front of the x in this one is also a half. Therefore, this one, because it's also in the form y equals mx plus c, also has gradient of a half. So line 1 had a gradient of a half. We can now say that line 2 also has a gradient of a half. We then need to just simply conclude that Oscar must be correct. He's correct because we've shown that both lines have the same gradient, and if both lines have the same gradient, that's logically equivalent to saying they're both parallel. So your final answer says something like this: yes, Oscar is correct because both lines have the same gradient of 1/2. Question 10, Alia bought a car. So it talks about the first year she bought the car, it depreciated. The second year it depreciates again. At the end of the second year, we're told what it was worth. What was the value of the car when Alia bought it? Well, before we properly get into this in any depth, it's always worth mentioning the key fact. And in my opinion, for percentages questions, the key fact is always this. Essentially, before anything happens to a value, it begins as 100% of itself. So let's have a look at this first bit about the first year, what it says. says here, after she bought the car in the first year, its value depreciated at a rate of 23% per annum. So what does this mean? Depreciate is a fancy word for loses or goes down. So its value went down at a rate of 23% per annum. Now, annum is a fancy word for year. So annum just means year. So it's gone down by 23%. But remember, it starts off as 100% of itself. So 100% minus the 23% means we're left with 77% of its initial self at the beginning of that year. And as a decimal multiplier, we can just type in on our calculator 77%, shift A and S button, press equals, then press S arrow D, we get 0.77, which is called the decimal multiplier. We're going to be multiplying by that value in just a moment. So then we say that the decimal multiplier for that step is 0.77. But then in the second year, it depreciates again. This time it goes down at a rate of 19%. At the start of the second year, it's 100% of its initial start of second year self. After losing 19%, it'll become 81% of its former self, and as a decimal multiplier, 81% is the same as 0.81. So essentially, it starts off being some value, which we're not sure about, and ends up being this after 2 years. So the value of the car when she bought it, we don't know. If in algebra we don't know something, what do we normally call it? Well, we normally call it x. So we can form an equation starting with x. So we start with x, we multiply by 0.77, which illustrates the 23% loss for the first year. We then multiply again by 0.81, which illustrates the 19% loss for the second year. And then we say after those two losses for the first and second year, that must now equal this value here of £10,914.75. So in other words, the equation we're going to have is this. Initial value, after the first year it loses a bit of value, times by 0.81 for losing 19% at the end of the second year. That gives us its final value. So we can actually simplify this quite a lot. So first of all, 0.77 multiplied by 0.81, we can work out. That gives us an answer of 0.6237. So x multiplied by 0.236, was it? Yep, equals 1091475. So therefore, to get x on its own, we just divide both sides by 0.6237. So x must be 10914.75 divided by 0.6237. So what we need to do on the calculator is we can press a fraction button, type in 10914.75, divide that by the previous answer we just had, which of course was 0.6237, press equals, and we can see that therefore the initial value of Alia's car must have been £17,500. And so that's all we need for question 10. Question 11, we have an experiment about 60 students completing a puzzle. We have a cumulative frequency graph shown here. We're told that these 60 students, the least time was 24 seconds, the longest time was 96. On this grid here, draw a box plot for the distribution of the times taken by the students. I'm just going to remind you what a general box plot always will look like. It's going to look like this. You have a box in the middle, and a left side end and a right side end. These used to be called whiskers, normally not called that anymore. But the first vertical line, there's 5 in total as you can see, 1, 2, 3, 4, 5. These 5 vertical lines in order, the first one is the absolute minimum value, this line here is the lower quartile, the third line represents the median, the fourth line is the upper quartile, and the fifth and final vertical line is the biggest value. And to make the box, we just make a rectangle out of the 3 vertical lines in the middle, and from the middle of the second and fourth vertical line, draw a horizontal line from the middle of it to the end to meet the first vertical line, and from this point, a line across to meet the final vertical line. So taking it step by step, are we told the minimum? Well, yes, we are. We're told the minimum time, the least time was 24 seconds. So that's our first vertical line. So pop in a vertical line at 24, which is 22, 24 here. So let's add this one in like so. We're also told the greatest time was 96 seconds, so we can add in the fifth vertical line at 96, which is here. Now we need to work out the lower quartile, median and upper quartile. There were 60 students in total. The median is going to be halfway in between these students. So imagine all the students in line from the 1st to the 60th. The median, the middle one, will be about the 30th. Basically half of 60 is 30. So to find the median, we're going to read off at 30 and read down when we hit the curve to read off what the median time was. So across at 30, then read down when we hit the curve. We can see here that that's going to be about 54 seconds. So the middle line, the median, goes at 54. Now the lower quartile, we read off at a quarter of a total, or half of the median. A quarter of 60 is 15, so we're going to read along and down from 15 in the same way we did with the median. So read along at 15, then go down. We can now see that the lower quartile is about 42 seconds. So we add in another vertical line at 42. Finally, we come to the upper quartile, which is 3/4 of the total. So 3/4 of 60 is 45. So we read off at 45, read along at 45, and then go down when we hit the curve and read that value off for the upper quartile time. So read along at 45 like so, and then go down from that point. We can then hopefully see that this upper quartile must be 64 seconds. That's our fifth and final vertical line. So there we have it. Then we just need to make the box plot around this. So straight line, straight line, straight line, straight line, like so. And then we've done it. That's our box plot, all done and dusted, using a combination of this information and reading off the median and quartiles from the cumulative frequency graph. Question 12, we have number of insects in a population at the start of year n is p subscript n. The number of insects in the population at the start of year n plus 1, in other words, the next year along, is p subscript n plus 1, where pn plus 1 and pn are related by this constant k. All this means is the next year along is the previous year's population multiplied by k. We're also told that k has got a constant value of 1.13. Find out how many years it takes for the number of insects in the population to double. You must show how you get your answer. Before I dive into the solution, I'm just going to try and talk through what this question is actually talking about in the first place, just to try and give a bit more understanding. So let's think of this in a table first of all. Start of year and then the value. So at the start of year 1, that value is going to be p subscript 1. For next year will be year 2. Now for year 2, that's going to be k multiplied by the value for the year before. So p2 will be k multiplied by p1. For year 3, that'll be k multiplied by p2, but p2 was kp1. So that's going to be k lots of kp1. K times k is k squared. For year 4, that'll be k times p3, but p3 we just worked out as k squared p1. So a pattern's going to emerge here. The end of the year value will always be a certain number of k's to a certain power, always multiplied by p1. So if I count for a few more years, year 5 and year 6, and it just continues like so. So it's actually asking us how many years it takes for the number of insects in the population to double. So at the start of year 1, how many years have gone by? 0 years have elapsed. In other words, that's a fancy word for gone by. At the start of year 2, that's after 1 year. Start of year 3, after 2 years, after 3, and so on. So what we're wanting is for the value to have doubled. In other words, for k to some power multiplied by p1 to be at least 2 times p1. So we know that k is 1.13. So let's, for example, try after 5 years. So after 5 years, is essentially this one here. For 5 years, the value is going to be k to the power 5 p1. In other words, 1.13 to the power 5 p1. Now, what is 1.13 to the power 5? Well, luckily we have one of these to tell us. So 1.13 to the power of 5 is 1.84ish. So that's about 1.84 times p1. That's not almost doubled. That's basically 84% increase on p1. We want this value here to be at least 2. If you multiply something by 2, that's doubling it. So that isn't doubled yet, but after 6 years, the value will then be k to the power 6 p1, which is 1.13 to the power 6 p1. 1.13 to the power 6. I can just multiply that value there by another 1.13. This time I get 2.08. And that there tells us that it's now more than doubled, because 2.08 is now more than 2. So therefore, doubles after 6 years. Well, actually, a double in between the 5th and 6th year, but after the 6th year, it's more than doubled. So it just says how many years. It doesn't say to use a decimal, so we can say doubles after 6 years. For part B, it says the value of k actually increases year on year from its start value of 1.13 in year 1. How does this value affect your answer to part A? Well, k is just the value we're multiplying the original population by. So if k is increasing and we're multiplying by bigger and bigger values, it will get to double much quicker. So actually, this would likely affect our answer from part A by shortening the number of years that we'd actually need. So if anything, for part B, this should affect our answer by shortening the number of years. So it would take less time to double. I'd leave it as less time, fewer years, you could say, I suppose, to double, because we're multiplying by a bigger and bigger number, so it's going to double, or get to the doubling point faster. Question 13, A and B are points on a centimetre grid, and it says A is a point with coordinates -7, 6, and that B is a point with coordinates 8, -5. Work out the length of AB, give your answer to one decimal place. With questions like this, when we're talking about lengths and coordinate grids, I'd always suggest to just sketch out the grid itself, so you can just picture what you need to do better. You could do it abstractly, but I think that makes it much harder. So here's a sketch of the grid that I did earlier. And now we can add on some points. So obviously we've got A and B to add in. So A is -7 and 6. That's going to be somewhere here. So I'm just going to add in A in red. So it's -7 this way and 6 up. B is 8 -5. So 8 to the right and 5 down. So 8 -5, like so. Then it says to work out the length of AB. Now, AB just means the length from A to B. So it's just this diagonal length here from A to B we need to find, which I'm going to put in green. So what we can do here, we can construct a triangle between A, B, and this base here, which we can make right-angled like so. So thinking vertically, A goes from 6 down to B, which is -5. So this bit here is 6. This bit's a length of 5. So in total, this bit's 11. And then as we go from -7 to 8, from -7 to 0 is 7, 0 to 8 is 8, so 7 plus 8, the length of the bottom will be 15. So it's a right-angled triangle, this side's 11, that side's 15, so if I just focus on the triangle now, we can think about what theorem we can use to work out the length of the hypotenuse of a right-angled triangle when we know the two other sides. I'm hoping it's come to you as well that this is a Pythagoras question now. So the length of the hypotenuse, in other words AB squared, is going to be the same as 11 squared plus 15 squared. So AB squared is simply the sum of 11 squared plus 15 squared. So we may as well work this out. So AB squared, 11 squared plus 15 squared. Now's a good time to get the calculator out and ready. So 11 squared plus 15 squared. What's that going to be? 11 squared plus 15 squared. That gives us a total of 346. So we can just write this down. Therefore, to work out what AB is, we just need to square root that. So therefore, AB is going to be the square root of 346. So if we just go into the calculator and square root that answer, square root A and S, press equals, press S arrow D to get it into a decimal. And we want it rounded, it says, to 1 decimal place. So that's going to be 18.6. That 6 won't round up because it's only next to a 0. So it just stays as 18.6. And the units, because it's a centimetre grid, are going to be centimetres. Hence our final answer is 18.6 centimetres. Question 14. Using algebra, prove that 1.062 recurring, that dot means the 2 goes on forever, can be written as the exact fraction 1 and 14 over 225. The key thing here is it does explicitly say to use algebra. So the best thing to do from the very start is to call the recurring decimal that you're trying to prove as a particular fraction, we're going to call this x, or some letter anyway. I just call it x, call it p, z, doesn't really matter, but let's go for x, that's the most common one. So let x equal 1.062 recurring, which equals 1.062222 forever. So now we can set this up as a grid or table would be my suggestion, something like this. So what we're going to do first of all is we're going to write x down at the bottom. So x is 1.0622, and these dot dot dots just mean the 2's are going on forever. What we're going to do now, we're going to carry on multiplying this initial x by multiples of 10 until we can get another row above where it would be 10x, 100x, or whatever, so that if we were to do 10x take away x, or 100x take away one of the other ones, these forever going on 2's could be eliminated if we did one take away the other. So if I just write above here 10x, then 10x, what will happen if you multiply by 10? All these digits will just move one box to the left. So this one will go here, that 0 will transfer over to where that 1 was above, basically something like this. And so 10x will just be a 10.6222. Now actually what you could do if you wanted, just do 10x take away x. That would be fine. That would give you 9x equals, and then if we're taking away, this would cancel, that would cancel, cancel, and so on. We're just left with 10.62 minus 1.06, which if you tried on your calculator would give you 9.56. You could then say that x equals 9.56 over 9, and then you get 956 over 900. If you want to multiply both top and bottom by 100, this will now simplify. So the clue here is it becomes 225. So we can divide both the top and bottom by 4. I'll show you another way in a second, by the way. 956 divided by 4, because it's a clearly proving question. So 956 divided by 4 gives us 239. Then finally converting into a mixed number, that's the same as 1, and 239 take away 225 leaves us the 14 left, which is our remainder. So we have 14 over 225, which is what we wanted to prove all along. I'll show you another way though, so you could sort of get away with dealing with these decimal numbers. A more neat approach is to keep multiplying by powers of 10. So if I were to just take this 10x and multiply by 10 again, another way I could arrive at this solution would be for me to get 100x equals 106.2222. Then if I multiplied by 10 again to get 1000x, I'd find that 1000x would be 1062.2222. Now, if I were to do 1000x subtract a single x, in fact, or even 1000x take away 100x would be better, because all these 2's will cancel off. So if we think about this now, and do 1000x take away 100x, and we can do our subtraction here at the bottom, then 1000x take away 100x will obviously be 900x's. And then if we do the subtraction, obviously 222 take away 222, that will all cancel there. 2 take away 2 cancels, and so on, and so on, and so on. And so then we have A whole number, because all the decimal parts have cancelled off neatly and perfectly, will then just have 1062 minus 106, which gives us, of course, 956. So that would be, in my opinion, a neater way of doing it. So then we can say 900x equals 956. So therefore x equals 956 over 900. We can then divide both top and bottom by 4 to get the required denominator of 225. And so that gives us next 239 over 225. Finally convert into a mixed number. We get 1 and 14 over 225 as required. So there's a few different ways of doing it. Getting it so that the decimal parts all vanish neatly tends to be the favoured method. I don't really mind which one you use, as long as it's algebraic and you're doing one row minus another to make sure all the recurring parts cancel perfectly. So that's one way of doing it, probably the most common. Question 15. Fiverr is studying the population of rabbits in a park. It goes on to mention she's catching some 20 rabbits, marks them, and then releases. So before we focus on the actual question in depth, if something's going to be captured and then released, this is called capture, recapture. So if you want more practice on these questions, Google capture, recapture, GCSE. There's a key concept for these questions, which is as follows. So the general idea, the key concept is the best estimate of a fraction of tagged individuals when recaptured is going to be pretty much the same as a fraction of the entire population that was tagged in the first place. So let's think about how many which were recaptured were tagged. And it says here in this third paragraph about Tuesday. So it says on Tuesday she caught 42 of the rabbits and 12 of them have been marked with a tag. Monday she caught and marked 20. Then they were released. So they've been spread out and dispersed. Tuesday she finds that out of the 42 she's captured, 12 have been marked. So 12 out of 42 rabbits have been marked. That fraction simplifies down to 2/7. So simplified down, we can see that as an approximation, hence a squiggly equals, we're guessing about 2/7 of these rabbits were tagged. But how many were tagged? Obviously in the first place, there were 20. 2/7 we can picture in rabbit form like this. And I'm going to imagine, stupidly, that the marked rabbit's been marked with a Superman logo. No trademark infringement intended. So 20 rabbits have been marked. In other words, 2/7, thinking of it purely mathematically without a silly picture. I thought this might amuse some people, or maybe I'm just being a bit silly. 2/7 is basically must be the same as the 20 which were marked out of the grand total number of rabbits in the population, the grand total in the park, which is what we're wanting to find. So if those two bunnies at the top represent actually 20 rabbits, each bunny picture, I'm thinking, can represent 10 bunnies. Those 20, so 10 here and 10 for that one. Therefore, we've got 7 lots of 10 at the bottom, because we've got 7 bunnies at the bottom. So 2/7 is 20 out of 70. In other words, 20 out of the 70 rabbits in total in the park were marked. In other words, our best estimate, there must have been about 70 rabbits in total. Part B, Albie is also studying the population of rabbits, but in a different wood. One day he catches 55 rabbits and finds that 40 of them are marked with a tag. Albie then estimates that there are 50 rabbits in the wood. Part B is just to explain why Albie's estimate can't be correct. Well, he's caught 55, which means there must be at least 55. But then if he estimates that there's 50 rabbits in the wood, well, what's happened to the 5 that he caught? So his estimate can't be lower, surely, than the number he caught in the first place. It's just a nonsense. So I'd suggest we write something along the following, something like this. If he caught 55 rabbits, there clearly must be at least 55 rabbits there. But his estimate is lower than the number he tagged, so he can't be correct. Something to that effect will allow you to pick up full marks and gain full credit for that part B. Question 16, we have a shaded region shown on this grid is bounded by 4 straight lines. We need to then find the 4 inequalities that define the shaded region. The first thing I'd suggest we need to notice here is that all 4 of these lines which enclose this grey area are all solid lines without dashes. So if the lines are solid, that means it's going to be the symbol less than or equal to. So all of these inequalities are going to be using these symbols. If these symbols were dotted lines, it'd be symbols strictly greater than or strictly less than. But because they're filled in solid lines, less than or equal to, or more than or equal to. So because all these are black lines, and to just help me explaining it, I'm just going to go over them in different colours, just to help my explaining it in this video for you. So I'm just going to colour them like this: a red line, green, blue and purple. So this red line at the top is a horizontal line crossing the y-axis where y is 6. The horizontal line crossing y when y is 6 is simply the line that y equals 6. So let's think of these 4 different lines in isolation. So the first one, like I say, this one's just going to be y equals 6. So we actually want the inequality version of this though. So the region we've got here, you can see clearly, is below where y is 6. So we want y to be lower than 6 down here. So we adapt the equals and say therefore y needs to be less than or equal to 6. Next, let's think about this blue line. The blue line's a bit harder because it's a diagonal line, so we need to think in terms of y equals mx plus c. First of all, let's just add into the answer line that y is less than or equal to 6 for the red line. Then the blue, let's just take 2 nice points. So it crosses the y-axis at 6 and crosses the x-axis at 2. We can calculate the gradient by taking this point and that point and seeing that between that point and here, we need to go 2 along and then 6 up. So from this, we can work out the gradient of this blue line. So the gradient, m, is 6 divided by 2, which is 3. The other part of the ingredient we need for working out the equation of a straight line is the y-axis intercept. We can see clearly it crosses where y is 6. So therefore the y-axis intercept is 6. Putting these 2 pieces together, remember y equals mx plus c, the equation of this blue line would simply be y equals 3x plus 6. So we can add this in here. Of course though, we need it in inequality form. So the y we need is actually above that blue line. We don't want it down here. This region here, the grey, is actually above the line. It's on the higher side of it. So we're needing y to actually be greater than or equal to 3x plus 6 because the grey region is on the higher side of that line. So adapting this into the inequality, y is greater than or equal to 3x plus 6. So we can place this here as our next inequality we've found. Now the green line. Again, pick 2 points, and then we can work out the gradient and the equation of the green. So thinking of this green line, I'm going to pick this point here 2, where it crosses the x-axis, and this point here, which is 6 minus 2. So between these 2 points, we're going 2 down, 4 across. So we can calculate the gradient by doing change in y over change in x. So for this one, because we're going 2 down and 4 along, the gradient's minus 2 divided by 4, which is minus a half. The line is sloping downwards. The y-axis intercept, we can see it's between 0 and 2. In other words, the y-intercept is 1. Putting these 2 pieces together, therefore the equation of this green line is going to be y equals minus a half of an x plus 1. So we can now add this into our green area now, and then we can think about actually do we want this area to be higher or lower than what y is on this green line. The shaded area clearly is above the line, this green line, so we want y to be higher than a half x plus 1 because the shaded area we need is above it. So we just need to adapt our equals and say that therefore y is greater than or equal to a half of an x plus 1. So that's our third inequality we can add to our answer line. And the final one, the purple line, is again like the red one, well, the one I made red anyway, quite straightforward. It's a vertical line cutting the x-axis at the point minus 3. And so this is going to simply be the line where x equals minus 3. However, we need to consider what side of this purple line our region is in. Is it on the lower side of x or the higher side? Well, because x gets larger as we go to the right, clearly this region here is on the higher side of x. So we want x to be bigger than -3. For example, here it's about -2. So we want x to be greater than or equal to -3. So that's our adaptation. So that's our fourth and final inequality. So we add this one in. As long as we've got all these four listed properly in any order, we've got full marks for question 16. Question 17, I've underlined straight away the word similar. We've got two similar solid triangular prisms A and B. So if two shapes are similar and we want to do any calculations on a length, an area or a volume, we need to remember that if two shapes are similar, we can think of them in terms of linear, area and volume ratios. Our two shapes here are A and B. So if I do a little table to illustrate, if two shapes are similar, then their linear ratio, if one length is, for example, A and the other length is B, we can say the linear ratio of lengths is in the ratio of A to B. So whatever A is and B is, it's in the ratio A to B. So for example, I don't know, if this one was say 4 and that were 8.1, we'd have 4 dot dot 8.1. Then we can go from the length ratio to the ratio of areas by squaring both numbers in the above ratio. So if the length ratio is A to B, the area ratio between the two similar shapes will be A squared to B squared, and the volume ratio will be A cubed to B cubed. This is always the case when we have similar shapes. What we could do though as well, if this first number here for A, if we could reduce it to 1, for example by dividing both ratio parts by A, we can actually get here that the length ratio, we can call this one 1, and this other number here can be n, where n is whatever it needs to be. So if we can write the ratio in the form 1 to n, and do the same process here, so for example to go from the length ratio to the area ratio, we square both values. So 1 squared is 1, n times n becomes n squared. So if we can get the length ratio in the form 1 to n, the area ratio is 1 to n squared, you can probably guess what the volume ratio will be. It'll be 1 to n cubed. So let's see if we can do this with prism A and B. So we've got the volume ratio. Well, we can get the volume ratio quite easily. First of all, let's see what we're trying to work out though. We're trying to work out h, which is here. So you could bet anything it's going to link to the bigger height here. I'll add this on. So in terms of volume ratio, we've got prism A, which is 58.806 dot dot 1587.762. Quite horrible numbers. So if I were to divide both sides of this by 58.806, we can hopefully get this into a much simpler form, so it's in the ratio 1 dot dot n cubed. So any number divided by itself gives 1, of course. Therefore, doing this value divided by 58.806, let's see what we get here. 1587.762 divided by 58.806 gives us exactly 27, which is quite nice indeed. So therefore, the volume ratio is 1 to 27. So what we can do here, we can actually adapt this. So our n cubed is 27. But n cubed, if n cubed was 27, that tells us that the n must be 3. So this n we can replace with 3, and this n squared we can replace with 3 squared, which is 9. So therefore, the length ratio is 1 to 3, the area ratio is 1 to 9. If we didn't have a nice number, for example 27, which could be cube rooted, we could go from the volume ratio to the length first by just simply cube rooting both these numbers. The cube root of 27 is 3, and the cube root of 1 is 1. So that's a method that will work all the time. So anyway, we've now got the setup to work out what this big height here is. What we need to do is to recall the area of a triangle. So the area of a triangle is half base times height. So for this one here, we know the area is 43.74, so that must equal half times a base, which is 8.1, times of a height, which I've just called big H. So this can be rearranged. So 43.74, oops, I'll change colour into black. So 43.74, half times 8.1, I can just do that now, 1.5, 0.5 times 8.1 gives a value of 4.05. So we can work out h's by dividing both sides by 4.05. So therefore, the height of this one is 43.74 divided by 4.05. So 43.74 divided by 4.05. That's going to give us 54/5, which is 10.8. So, in terms of areas, we've got 1 to 9, length is 1 to 3. So if this height is 10.8 for the bigger shape B, then the smaller shape A, this smaller height H, because it's in the ratio 1 to 3, this one here is going to be 3 times smaller. In other words, if this is 1.3, we need to just divide this number by 3 to work out what H is going to be. So therefore H will just be 10.8 divided by 3, because according to this ratio, the length of a smaller one is 3 times smaller. So 10.8 divided by 3, that gives us 3.6. Therefore the height of this is 3.6 centimetres. H is unitless, H is just 3.6. A fairly awkward question, that one, but it is question 17, this is where they do get quite nasty. Question 18, here's a triangle. A very simple question in terms of there's not much writing to it, it's just simply work out the area. Give your answer correct to 3 significant figures. It's not a right angled triangle, so we can't do half base times height. It's one of these things you just need to know and have in your memory for the exam. The area of any triangle in general is always a half times A times B times sine C. In other words, if you know an angle, it's going to be half multiplied by one side times the other side, which make the angle, then multiplied by sine of the angle in between these sides. So if I just think about A as being in red, B being in blue, and the angle in green, I can say this one's my A, that's B, and angle C is this one here. So adding in the colours like so, we can just plug in these values into this formula and then just generate the answer using the good old calculator. So the area is going to be half times our A. I've designated A to be 11.2. It wouldn't matter if I called that B and this one A, as long as they're either side of the angle in question. So half times 11.2 multiplied by 4.3. Then multiply that by sine of 118. Then we just need to carefully use a calculator to do this. A common mistake is just do 4.3 times 118. Make sure it's sine of the angle. Absolutely. So, looking at for 1/2, multiplied by 11.2, multiplied by 4.3, multiplied by sine 118, close brackets. That gives us a value of 21.26, and so on and so on. We need it to 3 significant figures. So 21.2 might be right. 1, 2, 3 significant figures. However, that 2 is next to a 6. That 6 will force the 2 to round up to a 3. Therefore, our answer is 21.3 centimetres squared. Question 19, we have to solve this quadratic 6x squared plus 5x minus 6 equals 0. Now, there's actually 2 ways of doing this. Normally on a calculator paper, they'll say something like give your answer to 1 decimal place or so many significant figures. And if they say to round it to so many significant figures or decimal places, that's a massive clue to use the quadratic formula. They've not done that here, which doesn't mean you can't use a quadratic formula, There's a bit of a hint that actually this one actually does factorise, which is pretty rare for this type of question so late in a paper. So I'm going to show you both ways, how to do this via factorisation and how to solve it using the quadratic formula. Now, the way I factorise, a few people have mentioned, again, when I talk through these videos, like, it's a bit of a strange method I use. So what I'm going to do here, I'll link you to, in this very video and in the description, a bit of a further, deeper guide why I factorise and the way I do. So the way I do it is, firstly, let's just see if 6, 5 and minus 6 have any common factors in them. They don't. The highest common factor of 6, 5 and 6 is 1. So once you've checked that, you can now multiply the first number, the a, by the c, if you like, times those, and then we temporarily forget about this number. So I'm just going to write the 6 as 6 times 6 now. So the minus 6 becomes minus 36. So I think of it as x squared plus 5x minus 36 equals 0. So that 6 we've sort of forgotten about. We've multiplied it by that minus 6, but this 6 will come back into play later on. So the next thing we're going to do is we're going to now factorise this as normal. So two numbers that multiply to minus 36, but when we add them together, we get 5. With a bit of thinking, you should spot that it's going to be x plus 9 and x minus 4. So what we now do is we're going to next put that 6 back in underneath both numbers in these fractions, in these brackets, sorry. So we write 9 over 6, and we're going to write 4 over 6 as well. Now we're going to see if this simplifies these fractions. So simplify them as low as they go. 9 over 6 we can simplify to be 3 over 2. 4 over 6 we can simplify down to 2/3. And then any number that's left on the bottom of fractions, any number bigger than 1, we just chuck to the front and put it in front of the x in the bracket. And then we factorised it fully. So we get 2x plus 3. And that 3 goes to front to make 3x minus 2. So we can now go back to the equation and find when this is equal to 0. The bit of a hack here is actually you've got your solutions at this stage, but I wanted to go on fully to show you how it would factorise. This isn't factorised, but this is good enough to show you the solutions, as is this, of course. So what we need to think about is what value of x in the first bracket would make this bracket equal to 0. So 2x plus 3 equals 0. If you solve that equation, you should find, if a minus 3 from both sides, then divide by 2, x is minus 3 over 2. The same fraction here with its sign switched. So therefore, the first solution for the first bracket is x is minus 3 over 2. And the second solution from the second bracket, if I solve 3x minus 2 equal to 0, by adding 2 to both sides, then dividing by 3, we get x is 2/3, which you can see here is the same as this value with its sign switched from a minus to a plus. So the two solutions, minus 3 over 2, or x equals 2/3. I'm going to show you probably the safer method for a calculator paper, which is using the quadratic formula. To remind you what the quadratic formula is, it's this thing here, where a is the value in front of the x squared term. So our a in this case is 6. B is the number of x's, which is positive 5. So b is simply 5. And c is the constant number on its own with nothing to do with the x. So the c here isn't 6. That's a common mistake. C is minus 6. So if we substitute these values in, we get x is going to be minus 5 plus or minus the square root of b squared, which is 5 squared, minus 4 multiplied by a is 6, multiplied by c, and c is minus 6. All of that divided by 2 lots of a, and a is 6 of course, so divide by 2 times 6. So we just type this into our calculator with care, like so. So it's a fraction, so I may as well press the fraction button first. So minus 5. I'll go for the plus option first, so plus square root of 5 squared minus 4 multiplied by 6 multiplied by minus 6, all divided by 2 times 6. You could put 12, I'm just being lazy. And then we get 2/3. And the second solution, we switch the sign of the root from plus to minus, or from minus to plus if we did the negative root first. I did the positive root first, so I'm going to change that plus to a minus, and we get the second root 3/2. So therefore, x equals 2/3 or minus 3/2. Whichever method you prefer, use that one. Question 20, A, B, C, D, E, F, G, H is a cuboid. Sorry, I went back to regress to childhood there. AD is 9 centimeters, FD is 13, angle GHF equals 49 degrees. Let's add these pieces of information into our diagram carefully. So AD means going from A through to D. So the top edge going from left to right is 9 centimeters along. So we can add this one in there. And because it's a cuboid, from F to E will be 9, as will from G to H, as will B to C. So all these sides here, from one end to the other, will equal 9. So I'm going to add in 9 here and 9 there. I could have also added in that from B to C is 9, but we're not going to need to use that side, which you'll see later. Next, from F to D is 13 centimeters. So from F here, going diagonally up to D is 13. An angle GHF, which means the angle as you go from G to H, then diagonally to F. So this angle here is 49. So I need a line from H to F, then the angle in between that will be 49 degrees. So GHF is going to be this angle here, which I've done in green, in between GH and HF. That's 49. We need to find the size of angle FAH. Now from F to A to H makes a triangle starting from this edge, then sort of going into the shape. So it's hard to picture. So I'm going to try and do my best to illustrate where FAH is next. So I'm going to draw in and make a triangle in purple from F to A to H, then back to F again. And then I'm going to colour in the angle in yellow so we know what we're aiming for. So this is the angle here we're trying to find. But this triangle, FAH, I don't know anything about it. I don't know from F to H, I don't know from A to F, and I certainly don't know from A to H. So what we need to do first is to unpick this step by step. The first triangle I can see, which I know most about, is actually this front one here. So if I look at ADF, I know it's a right angled triangle because it's a cuboid. The top edge is 9 and the diagonal's 13. So I'll just focus on FAH for a second. I've redrawn it here so it's a bit clearer without all these lines going everywhere. I can now calculate AF using Pythagoras. So if we recall Pythagoras, AF squared plus AD squared equals the hypotenuse squared. So AF squared is what we're trying to find. AD squared will mean 9 squared and FD squared will be 13 squared. So filling in this information, that can be rearranged by subtracting 9 squared from both sides to get AF squared on its own, like so. So AF squared is 13 squared minus 9 squared, which equals 88. Final step to get AF, we then square root both sides, and you should find that AF is about 9.380831, if you check on your calculator. So I'm going to label in the length of that side here on the diagram. Next, what we need to find is, focusing on this base triangle, we could then think about finding FH. So I know one side of this purple triangle. If I can find a second, I can then use SOHCAHTOA to find the actual angle in question. But looking at this blue triangle at the bottom, FGH, if I just draw this out here, I can now think about how to find from F to H. It's a right angled triangle. It's not Pythagoras this time, because I'm not trying to find a side when I know 2 sides already. This is going to be trigonometry, SOHCAHTOA. So, let's label the side we want to find X. I want to find F to H. I'm going to call that X. Then we can label the sides accordingly. like I say, it's SOHCAHTOA, so just having this ready. The first side I tend to label is the opposite side. The side opposite to the angle is GF. So that's going to be the opposite. The hypotenuse is the longest side. I'm hoping you can see that's F to H. That's the opposite, like I just said. The other side is therefore always just labelled A to stand for the adjacent. So 9 is the adjacent. So what we're going to do now, we're going to colour code in on all of these triangles the side we know, which is A, and the side we want to know, which is H. So if I colour in yellow A and H in all of these triangles, I'm going to cross off O as well because I'm not interested in O. So just think about A and H. I can see here A and H only appears in the CA triangle. So that tells me that I need to use the cos function because C stands for cos. So to find X, which is the hypotenuse, I cover up the side I'm trying to find. So if I cover up H for hypotenuse, like so, then I can see H must be A divided by C. So I can write H equals A over C. A is the adjacent, which is 9, and C stands for cos of the angle in question. So C stands for cos 49. So A over C becomes 9 divided by cos 49. So if we try this on our calculator, press 9, scroll down, press cos 49, close brackets, and press equals. We can see that the hypotenuse must be about 13.718-ish. So write that down without rounding it too much yet. Only really round when you get to your final answer to avoid any rounding error. So this hypotenuse from F to H is 13.718277. So I'm going to label this on here so that we can now see what we need to work out. So we can actually now work out FAH, this angle here, because this purple triangle, I know two sides of it, and I know it's a right angled triangle, so again I can use standard trigonometry, SOHCAHTOA, to work out this angle. Again, this diagram looks quite confusing, so I'm just going to focus on triangle FAH next, say goodbye to that. So a triangle FAH, just focus on this one there, is 9.4-ish high, 13.7-ish along, unknown hypotenuse. That's the angle I want to find. So colour coding it in green, I'll just pop it here so we can see it much clearer. Now label on the sides, like we did before. So that's the angle I'm trying to find. The side opposite to that is this one, so that's my O. The hypotenuse is that one there. I don't know it, and I don't want to know it, so I'm just going to cross that off. And the other side, therefore, is the adjacent. So because I know A and O, the SOHCAHTOA triangle, which includes A and O, is TOA. Because we're trying to find an angle, we are going to cover up T for tan. And so we're going to do O over A. And you need to remember, when you're finding an angle, it's either going to be tan minus 1, sin minus 1, or cos minus 1. Because we've done TOA, which is tan, the angle, therefore, is going to be tan minus 1 O over A. So that's going to be tan minus 1 of whatever the opposite side is. So that's 13.718277 divided by the adjacent, which is 9.380831. Then after we can round it to the nearest degree, but not before. So shift tan minus 1, press fraction, put 13.718277 on top, and on the bottom put 9.380831. Close brackets, press equals. We get 55.6. Round that to the nearest degree. 55.6 will round up to 56 degrees. That is not an easy question. Well done if you manage to get 56 degrees. Question 21. We have a graph which gives a volume in litres of water in a container t seconds after the water starts to fill the container. Calculate an estimate for the gradient of the graph when t equals 17.5, showing how you get your answer. The gradient of a graph is a change in y divided by the change in x. And if it's a straight line graph, it's easy. But if you've got a curved graph, or any curve, to find the gradient at any particular point, at this point 17.5, we need to do a tangent to that point. So when t is 17.5, we need to do a tangent to the curve at that point. So at 17.5, we're looking at this point here. So I'm going to add in a dot there, and a tangent is just a line that sort of scrapes a curve and just touches at a particular point and then goes off again. It doesn't cut the curve, it just touches at a single point. So the tangent, I'm going to draw in red. You need to draw as accurately as you can, and it should look a bit like that. Yours might be a bit steeper or a bit less steep, but it shouldn't be too far away from that. Once you've drawn your tangent, pick two different nice points which go through the corners of squares on your tangent line. So for mine, that one there seemed to go nicely through that square, and I know 17.5 is on the is what the tangent goes through. So I can read off here. I can see that's about 10.5. So I'm picking the blue dot and there for my own points. You pick your own as long as they're nice and clear and aren't too close together. So the gradient is a change in y divided by the change in x. So reading at this point, each little square is half a unit. 5.5, 6, 6.5. That's 7, and that one there's 17.5. And this graph here goes 10.5 high. So from here to here, it's going from 7 to 17.5, and from 0 up to 10.5. Gradient is change in y over change in x. So we've gone 10.5 up, that's a change in y, and the change in x is a difference in between 17.5 and 7. 17.5 take away 7 is 10.5. So weirdly, I get 10.5 divided by 10.5. Mine strangely gives me exactly 1. You may have got a different answer, and as long as you're within a certain tolerance, that's absolutely okay, because drawing a tangent at GCSE isn't an exact science. It becomes one at A-level, but not for GCSE. So as long as you've done a fairly accurate tangent, I can tell you that answers in the range of 0.9 to 1.2 inclusive will be allowed, as long as, of course, you've not guessed it, and as long as you've drawn it from a valid, clearly drawn tangent. So you still need the correct method. You can't just guess your way to the answer, but they do allow you some tolerance and wriggle room in case you've done your tangent slightly different, because the examiners do know, in fairness, it's hard to gauge exactly how steep it should be. Part B, describe fully what the gradient in Part A represents. A tangent, or the gradient, tells you the rate of change of y in relation to x. In our case, it's rate of change with volume in relation to time. So it's the speed or rate of change of volume per second. You don't need to go that much in depth. The main thing of a tangent is it is a rate of change. It tells you the rate. So what to say here, keep it nice and simple. It just tells us the rate of change of whatever's on the y-axis. It's the rate of change of volume. It's always a rate of change when it's time on the x-axis. So question 22, we're towards the end of the paper now. This question, then another 2, and we're done. So this is about functions and finding inverses. So we're told f of x is the cube root of x, and that g of x equals 2x plus 3. H of x is a composite function, it's f of g of x. We need to find h minus 1 of x, and this is just notation. It's not a power, it's not 1 over h. This is notation for finding the inverse function of h. So we need to find h first and then inverse it, but h itself, if we need to find that, is a combination of f and g. We need to remember, with our composite functions, we start from the end and work backwards. So h of x actually means we're applying f to all of g of x. So we're doing f of g of x. So normally, f of x just takes the input, which in this case is x, and cube roots it. So whatever the input is, the standard input for these functions is x. If we f x, the input just gets cube rooted. So based off that idea, if our input into f is actually g of x, then rather than cube rooting just the x, we'd cube root the new input, which would be g of x. Only thing I mean by that is, whatever f is, whatever the input is into f, we cube root it. So I think of it as f of whatever is the cube root of whatever. Our whatever here is g of x, so we just cube root that thing, whatever it happens to be, in this case g of x. Of course though, we know that g of x actually is 2x plus 3, so therefore we can go one further and say h of x, which is the cube root of g of x, must be the cube root of 2x plus 3. So we're almost actually done now. We've done the hardest part by far. I'm just going to write this on its own line and say, therefore, we know that h of x is the cube root of 2x plus 3. But of course, we don't want h of x, we actually want h minus 1 of x. So how do we find the inverse? Well, we can actually do it in just 2 steps. So to find the inverse, our first step is we need to arrange h of x, which in this case is this, to make x the subject. So at the minute, this x is trapped, it's being cube rooted. So the first step here would be to cube both sides of this to undo the cube root thing. If we cube the cube root, it basically cancels this surd and we just get 2x plus 3 back again. If we cube h of x though, we get h of x all cubed equals 2x plus 3. So we need to have x as a subject, so the next thing we need to do would be to subtract 3 from both sides, so we're just left with 2x. So therefore we see that 2x must be h of x cubed all minus 3, and then the final step to go from 2x's down to just 1x, we can just half both sides, which of course is dividing by 2. So therefore x equals h of x all cubed, take away 3, and all of that divided by 2. The final step seems quite strange. All we need to do is perform a switcheroo with x and h of x essentially. So just relabel x as the inverse function. So actually this we need to relabel as h minus 1. So therefore h minus 1 of x equals, get the fraction ready. We also need to swap h of x here with x, because x is the standard input. When we do these functions, as I say, the standard input needs to be x. So rather than this input being h of x, we standardize it to just be x. So whatever x is, the inverse is going to be x cubed, because I'm switching h of x for just x, minus 3, all divided by 2. And that is therefore our inverse function. Question 23, we're talking about bounds, upper and lower bounds. So a race is measured to have a distance of 10.6 kilometers, correct to the nearest 0.1 kilometers. And Sam apparently runs this race in a time of 31 minutes, 48 seconds, correct to the nearest second. So let's just think about these in a bit more depth. So the 2 bounds we need is going to be a bound for the distance, an upper and lower bound, and we need to consider a bound for the time. However, if you notice about the time, it says here it's correct to the nearest second, but here we've got a mixture of minutes and seconds. So what we need to do first of all is to convert this into just purely seconds. There's 60 seconds in each one of those 31 minutes, so we've got 31 lots of 60, 31 multiplied by 60, plus an extra 48. So actually the total time in terms of just purely seconds is 1,908 seconds. We can now think about these bounds for both distance and time by considering a number line, something like this. There's more than one method. I tend to do a number line, something like follows. So this is a number line for the distance, nearest 0.1. So what I do here is imagine a 0.1 times table, creeping up until obviously we get to 10.6, and a few 0.1s surrounding it. Same here, correct to the nearest second, so the time number line, because it's nearest second, nearest unit, we just count up in seconds until we get to 1,908. Not literally, but just imagine a section of that number line with 1,908 in the middle and going up in seconds and down in seconds on either side. Now we can consider the bounds. So, if the distance was 10.6 to the nearest 0.1, what that's saying is if we rounded it, it must be closer to 10.6 than to 10.5, and must be closer to 10.6 to 10.7. So it's got to be more than halfway, or at least halfway in between 10.5 and 10.6, but it can't be any more than halfway in between 10.6 and 10.7. So the bounds here are the halfway points here and there. Similar idea for 91908. The bounds for that one will be here and also there. So in other words, the boundaries, upper bound and lower bound for both, the minimum distance, d min, will be 10.55, maximum distance will be 10.65 kilometres. Similarly for the time, the lower bound of the time will be 1,907.5 seconds, and the upper bound of time will be 1,908.5 seconds. We are now asked about his average speed. It's told it's v kilometres per hour. At this point, it's worth remembering how to calculate speed in terms of distance and time. So speed equals distance over time, which, if we want to, we can use this formula triangle for. So if we want to calculate speed, we cover up s. Confusingly, it's called v. It's because v can also mean velocity, which is a signed version of speed. For this question, we can assume velocity and speed are one and the same thing. Not always we can do that, but we can do it here. So when it says v, it means speed. Cover up s, and you can see that speed is distance covered divided by time taken. So the upper bound of v will be when this fraction d over t is at its greatest. D over t is going to be the biggest when the numerator is the biggest it possibly can be, and the denominator is as small as it possibly could be. The other way around, if we want to work out the minimum speed, v min, we want the numerator to be as small as possible and the denominator to be as large as possible. That will minimize v for us. So we now need to calculate these using these bounds given to us. So d max we've got is 10.65. So the maximum speed will be 10.65 divided by the shortest time. If you just apply some common sense, that would make more sense. The fastest person will be able to go the furthest in the shortest time. So maximize the distance, shorten the time. So divide that by 1,907.5, in other words, t min, and let's see what we get for that. So just doing it here on the calculator. Whoops a daisy, got a bit of a slip of a pen there. Never mind. So we've got 10.65 on top, all divided by 1,907.5 on the bottom. You'll get a horrible decimal, that's fine. So that one is going to give us 5.583 and so on and so on. So 5.583 times 10 to the minus 3. Now you might be thinking, why is that number so small? Well, let's just consider the units we've used here. We've done kilometres divided by seconds. So the output is going to be kilometres per second. How many seconds make an hour though? Remember, we want our answer to be in hours. So what we're going to do here, we're going to multiply that by how many seconds make an hour. So this is per second, the distance covered. If I times by 60, that'll give me per minute. Multiply by 60 again, that will tell me kilometres per hour, which gives me 20.0996 and so on and so on. 20.0996. So to convert from kilometres per second to kilometres per hour, all I've done at that stage is multiplied by 60 squared. Multiply by 60 once, change from seconds to minutes, times by 60 again to change minutes into hours. That's the maximum speed, just over 20 kilometres. We'll do the same again, but working out the minimum speed. So the minimum value of d is 10.55. And we divide that by the maximum possible time. So minimum speeded person, they wouldn't go very far, perhaps, think of it like that, and they take a long time to cover that distance. So we're going to divide by 1908.5 and see what we get. So again, it'll be a small number because it's going to be kilometres per second. So 10.55 divided by 1908.5 equals, press SROD. Again, we get a very small number, this time 5.5279, and so on, 5.5279, blah, 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 multiplied by 10 to the minus 3, because again, that's in kilometres per second. So again, what we need to do there is to change into kilometres per hour by multiplying by 60 squared, just like we did before. So multiply by 60 squared, we get 19.900 and a bit more kilometres per hour. We now compare these two values. So we compare the 20.0996 and this figure here, the minimum. And when it says give your answer to a suitable degree of accuracy, what this means is we want to give our answer as accurate as we possibly can do without making it so accurate that these two bounds don't agree. So what's the maximum number of either decimal places or significant figures where these two answers agree? So would they agree, for example, if we rounded them to 3 significant figures? Well, to 3 significant figures, this one here would go to 20.1. That 0 would be rounded up to 1. But to 3 significant figures, that rounds to 19.9. So they don't agree to 3 significant figures. So we can't do it to 3 significant figures because they don't agree. However, if we round it to 2 significant figures, that one obviously become 20. And this one, 19.9, would round to 20. 20 equals 20, of course. So they do agree if rounded to 2 significant figures. That's why our maximum accuracy, where they both agree, is 2 significant figures. Therefore, we round our answer to 2 significant figures. So what we need to get full credit for this is evidence of how we arrive at this kilometres per hour. That's needed, absolutely. We also need evidence of arriving at 19.900. From these two, we make our conclusion and just simply say, therefore, we need our value of v to be, with certainty, 20 kilometres per hour. We can't be any more certain than that because the bounds disagree beyond the 2 significant figures points. And if you really want to impress the examiner, you might want to put in brackets that you've rounded to 2SF. If not, the examiner will give credit anyway. Finally, we've made it. Question 24, the very last one on this fairly gruesome paper. It's an equation of a circle question. So, first of all, we need to know about the equation of a circle. If we can't do that, we're stuck before we can even get off the mark. So, a circle has equation x squared plus y squared equals 12.25. You just need to know the equation of a circle is always in the form x squared plus y squared equals r squared for GCSE. So this number here, the 12.25, is the square of a radius. Common mistake, it is not the radius, that's the radius squared. So we can therefore find the actual radius of this circle by just simply square rooting 12.25. So do that, you can see that the actual radius of the circle is going to be 3.5. It's now a fairly good idea to sketch this out to make it less abstract and more real, so you can get a feel for what needs to happen in this question. This is the equation of a circle, always centered on the origin for GCSE, and we found out that the radius of the circle is 3.5. So do a circle over the axes in the middle and label the radius as 3.5. So something like this is what I'd strongly suggest you draw. That's the circle, that's 3.5, and each point it crosses the axes, will be at 3.5. That's x 3.5 minus 3.5. Y positive 3.5 minus 3.5 down here. We can now think about this point P and where it is. So coordinates of P, which is on this circle, is 2.1 and 2.8. So it's going to be 2.1 along, 2.8 up. So I'm going to put it here at the end of this particular radius. So I'm going to sketch on P here, and I'm going to think about the next step based on P. So there we go, it's 2.1 along, 2.8. So in a moment we can find the steepness of this radius line, in other words, the gradient of this radius. Before we do that though, reading on with the question, the line L is a tangent to the circle at point P. So a tangent just sort of scrapes the circle at the point it's a tangent to. So the tangent here is just going to be a straight line down, scraping the circle at P, but never touching or going inside the circle. So line L is going to be something looking a little bit like that. We need an equation of L in this weird form, which I'll explain later. What we need to remember about circles is that the radius and tangent, where they meet, they'll always meet at a right angle. So in other words, the green line, the tangent, and the red radius will be perpendicular to each other. We don't know anything about the tangent yet, but we can work out the gradient of this radius. So, the gradient of the radius meeting this tangent, the gradient of anything is always a change in y divided by the change in x. This radius is starting at the origin, so the change in y is just easily just 2.8. From nothing to 2.8, it's gone up by 2.8, and along, from 0 to 2.1, it's gone along by 2.1. So to calculate the gradient, it's just 2.8 divided by 2.1. If you try that on your calculator, what you should find is it gives you exactly 4/3. You could have done that without a calculator, but if it's a calculator paper, knock yourself out and use it. So 4/3. Now, the gradient of this the gradient of the tangent, L, will be the negative reciprocal. Remember, if one line is perpendicular to the other, the gradient of the line perpendicular to it is the negative reciprocal of the line it's perpendicular to. So, put simply, the gradient of this tangent, flip 4/3 on its head and stick a minus sign in front of it. So in other words, the gradient of L is going to be minus 3/4. Flip on its head to get 3/4, stick a minus sign. So now we can remember the equation of any straight line, I'm hoping, which of course is y equals mx plus c. Before we start considering this weird form here, let's just do the good old y equals mx plus c. M is the gradient, of course, of the line. We've worked out the gradient here is minus 3/4, so we can write this in. We don't know what c is yet, we can come to that in a moment. So L is going to have the form y equals minus 3/4 of an x plus c. To find c, we need some more information about this line. We do, however, know that this tangent goes through P, and so point P satisfies the equation of a tangent. So we can substitute in the coordinates of point P into this equation. So the next step is, we can just say here, because L goes through 2.1 and 2.8, we can sub in x being 2.1 and y being 2.8 into this equation. So in other words, 2.8 equals minus 3/4 of 2.1 plus c. From this stage, we can just work out what c is. So if I just work out minus 3/4 times 2.1, first of all, so minus 3/4 multiplied by 2.1, that gives minus 1.575. So minus 1.575 plus c. Then if I add 1.575 to both sides, that will give me what c is on its own. So in other words, therefore, c is going to be 2.8 plus 1.575. Now, I'm going to leave it this time as that fraction. So I'm going to leave it as 35/8. I'm going to say c is therefore 35/8. So therefore, the equation of L, now I know what c is going to be y equals minus 3/4 of an x plus c, which is plus 35/8. Like so. So I can say now, therefore, y equals minus 3/4 of an x plus 35/8. We can now come to this thing here. We want it in the form ax plus by equals just some number on its own, where a, b and c are integers. An integer is a number which is allowed to be negative but can't be a fraction. So essentially what we need to do here is to get rid of all these fractions. So we've got quarters and eighths. What's the lowest common multiple of 4 and 8? The smallest number in the 4 times table and the 8 times table is 8. So if I multiply both sides by 8, that will nicely get rid of all these fractions for me. So what I'm getting next is 8y minus 3/4 times 8. If you want to use a calculator, you can. That gives minus 6x. And then 35 over 8 times 8 just gives plus 35. Final step, I want the number c on its own. I want all my x's and y's on the left-hand side. So I want to get that minus 6x disappeared from here. To undo minus 6x, I add 6x. If I do it on the right, I need to do it on the left. And that, therefore, will give me my answer in the correct form, and then we're done with the question, and therefore done with the entire paper. So, therefore, in any order, you can put 6x plus 8y, or 8y plus 6x. I'm old-fashioned, I'm going to do it in alphabetical order. So, therefore, we've got that L is 6x plus 8y equals 35. And then we're finally done, and we can breathe a sigh of relief. There we go. Thank you very much for listening to that. I know it's always hard going through maths papers, but it is worthwhile. Please do realise that. If you have any questions, please do leave a comment on the comment section, or find me in school, or email if you know my email. Thank you very much for listening once again. Best of luck in all your exams, not just maths, and do take care of yourself. So from Mr. Bailey, it's goodbye for now, and tune in again very soon.